Hello students, welcome to Remote Maths classes. Today we are going to discuss about the chapter number 1 relation and functions in exercise 1.2 problem number 6. Let A is equal to bracket 1, 2, 3 and let of B is equal to 4, 5, 6, 7 and let F is equal to 1, 4, 2, 5, 3, 6 be a function from A to B so that F is 1, 1. Solution for this. Given set let A is equal to 1, 2, 3. Set B is equal to 4, 5, 6, 7. So function is given that f is equal to 1, 4, 2, 5, 3, 6. So function from A to B. Set of A is equal to 1, 2, 3. Set of B is equal to 4, 5, 6, 7. The function is related from 1 is related to the 4, 2 is related to 5, 3 is related to 6. So every element of A set A as distinct image in B. Therefore, F is 1 function from A to B. Next problem, 7th. In each of the following cases, state whether the function is 1 onto or bisective. Justify your answer. First one, f from R to R defined by f of x is equal to 3 minus 4x. Second one, f from R to R defined by f of x is equal to 1 plus x square. So first of all, we have to see that the first function f from R to R, function from R to R defined by f of x is equal to 3 minus 4x. First 1 function. 1 function says that let x1 x2 belongs to set of R such that f of x1 is equal to f of x2. F of x is 3 minus 4x. F of x1 means 3 minus 4x1 is equal to 3 minus 4x2. 3 and 3 cancel. So minus 4x1 is equal to minus 4x2. Minus 4 and minus 4 cancel. Therefore x1 is equal to x2. Therefore this implies f is 1. F is 1. Second, onto function. Let y belongs to the R. There exists at least one pre-image x such that f of x is equal to y. Here f of x is equal to 3 minus 4x. Y is equal to 3 minus 4x. Therefore y minus 3 is equal to minus 4x. This implies 4x is equal to 3 minus y. X is equal to 3 minus y divided by 4. X is equal to 3 minus y divided by 4 is this belongs to the set of R. Therefore f is onto, that is f of x is 3 minus y divided by 4 is equal to 3 minus 4 into x means 3 minus y divided by 4. 4 and 4 cancel. 3 minus 3 cancel, minus up minus y. Therefore this implies f of x is equal to y. If f of x is equal to y means f is onto function. Therefore f is 1 function and f is onto function. If f both 1 and onto means it is the bisective function. Therefore f is both 1 and onto, hence it is bisective function. F from R to R defined by f of x is equal to 1 plus x square. Here also f from R to R, f of x is defined as 1 plus x square. First one, 1 function. Let x1 is equal to 1, that is f of x1 is equal to f of 1 is equal to 1 plus 1 square, that is 1 plus 1 is equal to 2. F of x2 is equal to minus 1, f of x2 is equal to f of minus 2 is equal to minus f of minus 1 whole square is equal to, that is 1 plus of minus 1 whole square, 1 plus 1 is equal to 2. This is also equal to 2, this is also equal to 2. Therefore, f of 1 is equal to f of minus 1. The values of f of 1 and f of minus 1 are equal here because these two values are 2. Therefore, but 1 is not equal to minus 1. Therefore, this implies f of x1 is equal to f of x2, but x1 is not equal to x2. Therefore, f is not 1 1 here. F is not 1 1. Second one, on to function. Let belongs to the other. There exists at least one pre-image such that f of x is equal to y. Here f of x is 1 plus x is equal to y. Therefore, x is equal to y minus 1. X is equal to root of y minus 1. If we take y value is equal to minus 1, x is equal to root of minus 1 minus 1. X is equal to root of minus 2. Minus 2 is not belongs to the real number. It is